Hi, this is lesson 1-7 called Functions, and if you want to follow along, it's on page 47 of your textbook. Functions are special types of relations. We talked about relations in the last couple lessons that are just relationships between an X set of data and a Y set of data, and you have X's and Y's that go together. But in functions, they're a special type of relation. Every X we call X input. Every input can only have exactly one output. We call Y the output. So if I have X is 2 and I plug in the 2 and I get 3 for Y, so I have 2 and 3. The next time I plug in 2, I can't, for example, get -5 or something else. Every time that 2 has to have its partner 3. So when I input, it's like a machine that has to work. It's like if you walk right up to a candy machine and you can see a Snickers bar and you push the lever that's supposed to give you a Snickers bar. It functions if you get a Snickers bar every time. It does not function if you get, say, a liver snack instead or something like that. So every time we have an X, it will always have the same Y. We don't care about the Y's, we only care about the X's. Discrete functions are functions where we have separate dots. So you have like a graph and then you might have dots around. The functions are not going to have dots that line up over the top of each other. This one's a little iffy. Let's say these are not quite lined up top to bottom. A continuous function has a connected line or a curve. So whatever on the graph, it doesn't have dots, it has an actual line or curve. When we're looking at a graph, we can do a vertical line test. This is the easiest way to see a function. This is a function because I can draw vertical lines anywhere. Oops, that's not exactly vertical. And I only cross the graph one time. So that makes a function. Notice here, this is not a function. If I were to draw a vertical line here, I would cross the line twice. And that is not a function. Here, this one would be fine because here I have a dot. And right above it, I have an open circle, which means it does not include that place. So even though I can draw this line down like this and cross this dot, I'm not crossing anything when I get here. So this is a function. If we see the function as ordered pairs, we might see something like this. Here's an X that's 2. Here's an X that's 3, but here's an X that's another 3. And notice that this X has -2 as a partner, but this 3 has a 1 as a partner. So this is not a function. We notice that it is further not a function because here's another 2, and this 2 gets a 1, and this 2 gets a -2. So we say not a function. However, down here is x2, x is 2, x is 3, x is 4, x is 5. Whenever you have a situation where all your x's are different, this is always going to be a function because there's nothing, there are no x's that have different y's. If you see the term nonlinear function, that means it is not a straight line. Linear means line. So nonlinear functions might be something like that on a graph or any other kind of curve. Function notation is just a fancy way of actually changing how we write y. So I can have y here, same equation over here. I write this, we say f of x. So y is the same as f of x. It's a fancy way of saying this is our function of x, or in terms of x, meaning x is our independent variable and it's making things happen, and then the f of x, or y, is our output after the x makes things happen. So sometimes you'll see questions that say, what is the f of 5 written like this? The f of 5 just means plug in 5 for x. And so I'm going to take this function, 3x minus 8, and I'm going to plug in the 5 instead of x. So I have 3 times 5 minus 8, or 15 minus 8, which is 7. So the f of 5 is 7. This all takes a little getting used to. It's just a way of speaking. It's more grammar, so to speak, in our language of math. Okay, here's an example of a problem. It says for each relation, decide whether it's a function. Okay, in this domain, now notice that we have things that are not numbers or letters. That's fine. We have door goes with 6, desk goes with -6, pen goes with -7, and rock goes with -7. So each of the domain has only one output. So this is a function. Okay, relation 2, this 6 goes with 1, -6 goes with -5, but here's my problem. -7 goes with 5, and -7 goes with -9. As soon as we see that this -7 has 2 outputs, then it is not a function. We don't want to get a liver snack when we have pushed the button for Snickers. Okay, relation 3 has E going with E, Z going with E, B going with B, and N going with N. This is a function because none of my x's actually ever repeat, so there's no danger of it getting a second type of output. Relation 4 is a problem. We have a 4 and a 4 and a 4, and each of those has a different output, so that is not a function. We are always looking at the x. We don't care about the y, but if we have an x, it always has to have the same y. Okay, let's just do a vertical line test on these graphs. Notice that if I just draw vertical lines anywhere I want to, I can't cross the graph more than once. So this is fine, it's a function. But here, this is a problem. I can draw a vertical line and I can cross this graph twice, so that's not a function. And then when I have dots, I just have to look real carefully. Are any of the dots lined up exactly over each other? No, they're not, so that's fine. But down here in graph 4, 1, 2, 3, that is not a function. And then this is not a function, cross, cross, not a function. And this is not a function. I can cross it twice. I can cross it twice over here also. Okay, here, function h is defined by the following rule. Remember, rule, think equation. I've got this h of x equals 4x minus 4. That's like saying y equals 4x minus 4. That's fine. It means the same thing. Okay, so complete the function table. They just want me to plug in some values. So I'm going to plug in -4. Y equals 4 times -4 minus 4. I'm going to do that math. -16 minus 4 is -20. And then I have to plug in a -1. 4 times -1 minus 4. That's -4 minus 4, which is -8. And then I'll do one more. 4 times 1 minus 4. This is 4 minus 4, which is 0, and so on. You just plug in the numbers one at a time. I'll just show you one more thing. I might have said that this was the h of -4. That means plug in the -4. This is the h of -1. That means plug in the -1. This is the h of 1. And so you'll see it written like that. Here we have two different functions, and notice this one is called f of x and this one is called g of x. Both of those are y's. They're just fancier names. F of x is just a different name to specify this particular function compared to the g of x, which is a different one. This one happens to be cubic and this one happens to be linear. It's fine, but if I ask you for the f of -3, I'm asking you to plug -3 into f, not g. So in order to do the f of -3, I'm going to do 3 times negative 3 to the third power plus 5, because I'm picking the f of x equation. Negative 3 to the third power is negative 27. And I did not, whoa, stop that, not bring a calculator in here. Negative 27 times 3, we got to go one more. Right, negative 3 times negative 3 is 9, times negative 3 is negative 27, times 3, 80, oh, 81, of course it is. Negative 81 plus 5, that's positive, so it's going down. This will be negative 76, right? Yes, negative 76. And then the g of 5 tells me to plug in a 5. And by the way, you can have your calculator handy. I just didn't bring mine where I am talking right this minute. So g of 5, I'm going to use the g equation, negative 3. I'm going to plug in the 5 right where x is, and plus 2. So I have negative 15 plus 2 gives me a negative 13, correct? If I did my math right. That'll be the answer there, and that'll be the answer there. All right, now I have another function defined by the f of x equals 2x squared minus 5, and very tricky, I want to find the f of 4y. Don't freak out, you're just going to plug in 4y instead of x. So, watch this. 2 times 4y squared minus 5. Aha. Now you may or may not know what to do with this exponent right here. This might be extra tricky for you, but the exponent will go on the 4 and it will go on the y. So 4 squared is 16 and y squared is y squared minus 5. And so now I'm going to do this order of operations. 2 times 16 is 32. Y squared minus 5. And that's all I can do. I can't solve that any further. I'm just simplifying that a bit. Those might be a bit tricky for you. Give them a try. See what you can do. If you need some help, let me know. And I think that's it for 1-7. This wraps up chapter 1. So hopefully you're finishing up that objective. By Friday, we're done with chapter 1, moving on to chapter 2. So you have objective, foundations 1, or whatever it was I named it, that's due this Friday.